iSM is the client user interface for IPECs online partial discharge monitoring technology. The website is secure and password protected, with all users having their own personal account and user profile. When logged in, the user's homepage shows reports that are automatically generated according to user preferences. Selecting the Monitor tab brings up a panel with all of the substations in the client's monitored network listed. They are grouped by region or other appropriate category. Tick boxes allow them to be individually selected. The colour coding indicates the criticality status of the assets at each site. So for instance, a red site has at least one asset with the highest category of criticality. It can be seen here that the substation Manchester Road has one asset, Jeffrey Street, with a high criticality, and that is why it is shown in red. The monitored assets are displayed, ordered according to the criticality of the PD detected on each. Two bar charts represent the criticality of all of the assets in the substation. The top chart shows switchgear PD and the bottom chart cable PD. In this case, there is no local or switchgear PD, but there are a few circuits with high cable PD. The default setting shows both cables and switchgear, but we can, for instance, deselect the switchgear so only the cable assets are shown. If we select this cable asset with the highest criticality, summary information is shown. This is channel 28 on the monitor. It has a high criticality of 86, and you can see here, being a HV cable, the PD sensor type is a HFCT. This graph shows the variation in the PD magnitude over the last 2 weeks. And this graph shows the count. That is the number of PDs per power cycle over the last 2 weeks. This animated graph shows the phase resolved PD, or PRPD, detected over the last 48 hours. The timescale here is 1 power cycle. That is 20 milliseconds at 50 Hz, or 16.7 milliseconds where the power frequency is 60 Hz. This graph here shows the wave shape of the largest PD detected by the monitor over the last 24 hours. The PD activity for each channel can be analysed in greater detail. Here we can see the magnitude and the count. This is the PD energy, which is the cumulative PD detected over each power cycle. This is the raw unprocessed signal. In this case, it is similar to the PD magnitude, as clearly the discharge activity is higher than the noise on this circuit. This is the criticality. It has remained consistently high over the last 2 weeks. And this is the load on the circuit. It can be seen that there is a clear correlation between the load and discharge activity. In this case, the activity increases when the load, and therefore cable temperature, is higher. All the graphs are interactive and can be zoomed in and out. Here we can see 8 weeks of activity. It can be seen that there was a significant increase in the load for a couple of days, about 4 weeks ago. This caused a sharp increase in PD magnitude that has clearly damaged the insulation and precipitated an increase in activity that continues after the load pattern returns to normal. As a result, the criticality, which was already high at about 65, has increased to the current 86. This event is likely to have been caused by a fault on another circuit. This circuit was temporarily stressed with an extra load and has now been damaged and has an increased likelihood of failure itself. It demonstrates how HV faults often lead to further faults on neighbouring circuits. At this substation, there is high switchgear PD activity. There are actually 3 PD sensors in this case that are all sensitive to local discharge of different kinds. The ultrasonic acoustic sensor, the TEV capacitive sensor, and the HFCT, which detects PD from both cables and switchgear. With switchgear assets, The system also shows temperature and humidity, as these can influence discharge in switchgear. Here, the daily variation in temperature can clearly be seen. In this case, the highest levels are recorded by the TEV sensor, with the HFCT levels also quite high, indicating that the source is internal PD. Going back to the main selection, under the Alerts tab, you can set personalised alarms. Each user can enter their own email and mobile phone number. Alerts can either be sent by email, SMS text, or both, according to user preferences. Thresholds for each alarm can also be set on an individual basis or left at their default settings. Changes made to the settings are saved directly to the database. Reports can be automatically generated by the system. The system is configurable and IPEC will work with the client to agree report content, a design that is most suitable. Each report can be set up according to what the user would like to demonstrate. Active links in screen-generated reports take the user directly to the asset. In this case, one with high local PD. This just gives a high-level overview of the system, as there are too many features to include in a short presentation. iSM is designed to be a powerful analysis tool while remaining user-friendly and intuitive to use.